TEDBF takes shape, India's twin-engine deck fighter for carrier dominance. India's next big leap at sea won't be a ship, it will be the fighter that sails with it. The twin-engine deck-based fighter, TEDBF, is being designed to give Indian carriers a homegrown, high-end air wing built for rough seas, short runways, and long missions over water. Here's a clear tour of what TEDBF is, how it's engineered for carriers, and what it means for India's naval aviation in the 2030s. What TEDBF is solving. Carrier aviation needs more than raw performance. Fighters must launch off a ski jump, absorb hard deck landings, fold for cramped hangars, resist salt corrosion, and bring back unused weapons safely. India's current MiG-29K fleet does part of the job. TEDBF aims to replace it with a design optimized from day one for Indian carriers and missions in the Indian Ocean region. Airframe and carrier-proof design. Twin-engine canard delta layout for lift at low speeds and authority during high-alpha approaches. Reinforced landing gear, a arrestor hook, and a beefed-up spine to take repeated traps on a pitching deck. Folding outer wings and compact nose geometry to fit carrier lifts and dense hangar spots. Extensive marinization, anti-corrosion coatings, sealed avionics bays, and quick-swap line replaceable units for turnarounds between deck cycles. In-flight refueling probe and large internal fuel fraction to extend time on station without hogging deck cycles. Propulsion, launch, and recovery. 2 high-thrust afterburning turbofans in the 95 to 100 kilonewton class each, navalized, giving healthy thrust-to-weight for ski jump launches with meaningful bring-back loads. Stow bar, focus, ski jump takeoff, arrested recovery for INS Vikrant/INS Vikramaditya. Provisions and margins aim to be compatible with future catabar operations if India fields a catapult-equipped carrier. A launch planning accounts for wind over deck, fuel, and weapon mass so sorties can launch heavy loads in cooler night, morning windows and cycle lighter caps during hot afternoons. Avionics, sensors, and electronic warfare. Indigenous AESA radar navalized with maritime modes, sea search, periscope small target detection, and high-resolution SAR for coastline targeting. Passive sensor suite, IRST for long-range non-emitting detection and a 360 degrees missile approach warning system. Digital glass cockpit with sensor fusion so the pilot sees a single, decluttered picture, critical in salty, low-visibility decks. Full-spectrum EW, digital RF memory jammers, towed decoy, and expendables tuned for shipborne threats. Weapons and mission sets, fleet air defense, Astra family BV rams plus high off-bore sight WVR missiles. Maritime strike, anti-ship missiles in the BrahMos NG/Next Gen class, and smart glide weapons for standoff littoral targets. CADED, anti-radiation missiles, Rudrum class, and programmable decoys to crack coastal sand belts. Precision strike, LGBs, SAAW-type munitions, and GPS INS glide bombs sized for ski jump launches and deck bring-back limits. Networked tactics with carrier AEW helicopters and shore-based AEW&C for composite air pictures over hundreds of miles. Carrier integration and deck rhythm. Designed around Indian deck geometry, spotting footprints, lift clearances, and tie-down points. Turnaround built for Temco, quick engine and systems checks, modular weapon loading, and hot pit refueling to meet tight launch recovery cycles. Data links to surface combatants and P-8I patrol aircraft so the fighter can cue ship missiles or receive target quality tracks from the fleet. Operational payoffs. Longer legs and heavier bring-back than legacy jets mean fewer sorties to defend the carrier and more options in bad weather. Twin engines raise confidence over blue water. Canards and a big wing reduce approach speeds for safer traps. Indigenous supply chain and mission systems reduce foreign bottlenecks and allow faster software tactics updates. Development path and timelines. Big picture. It concept matured after carrier experience with MiG-29K. Wind tunnel and CFD work informed the Canard Delta and folding wing choices. A first flight and prototype test campaign paved the way for weapons separation trials, ski jump validation, arrested landing cycles ashore, and then at-sea trials. Entry into service targets the early mid-2030s, aligned with MiG-29K retirement windows and the need to field a majority Indigenous air wing. Risks and what to watch. Weight creep versus bring-back margin. Naval fighters live or die by approach speeds and hook loads. AESA EW integration in a salty environment. Reliability and maintainability must match performance. Engine growth path. Assured supply and future thrust upgrades keep launch margins healthy on hot decks. Okay, test tempo, arrested landing cycles, and sea trials take time. Schedule realism is a capability in itself. TEDBF is India's attempt to turn lessons from a decade of carrier flying into a purpose-built, sovereign deck fighter. The program holds its performance and reliability targets. Indian carriers in the 2030s gain a tougher combat air patrol, deeper maritime strike, and a truly Indian playbook for air power at sea. For deep dives on naval aviation, carrier operations, and India's homegrown combat systems, visit globalinfovita.com.